Albert Einstein, Relativity, the Special and the General Theory. Embark on an enlightening journey through Albert Einstein's profound work, Relativity, the Special and the General Theory. As you delve into this revolutionary perspective on the universe, you'll uncover the transformative concepts behind the constancy of the speed of light, the bending of spacetime, and the intriguing dance between gravity and acceleration. The theory of relativity reshapes our understanding of time, space, and reality itself, challenging the foundational Newtonian notions of the universe and unveiling an intricate tapestry interwoven with time dilation, space curvature, and cosmic determinism. Prepare for a captivating expedition that demystifies the complexities of Einstein's genius, portraying a universe that's both astonishing and mind-bending. The insights gained will not only enrich your understanding of fundamental physics, but also provoke deeper philosophical reflections on existence, reality, and the cosmos itself.
Light's unyielding pace. In the twilight of the 19th century, a conundrum baffled scientists as they relentlessly probed the nature of light. Armed with precise instruments, American physicists Albert A. Michelson and Edward W. Morley embarked on a quest to measure light's velocity as the Earth moved through the cosmos. Curiously, their groundbreaking experiment revealed that light maintains a steadfast speed, unaffected by the Earth's movement, a paradox defying intuitive understanding. Imagine turning on headlights while speeding in a car, expecting the light to gain additional velocity. Such assumptions falter before the brilliant insight of Albert Einstein. Rather than dismissing the Michelson-Morley results as flawed, Einstein postulated a radical notion that rewrote the rules: light speed is constant for every observer, irrespective of their motion. Light defies our common experience, governed by its unique laws. To illustrate this revolutionary idea, envision two friends, Alice and Bob. Alice stands on a train station platform, while Bob rides in a bullet train hurtling by. Each holds a stopwatch. The moment the train races past, they start their stopwatches simultaneously. Now, here's the twist: if Alice could peer into the train and see Bob's stopwatch, she'd witness a perplexing sight: Bob's stopwatch ticks more slowly than hers. There's no deception at play or trick of vision, but an authentic divergence in the flow of time itself. This counterintuitive phenomenon arises from time dilation, a key tenet of Einstein's theory of relativity. As objects like Bob's train zoom near light speed, time dilates, lagging compared to stationary or slower-moving objects. From Alice's vantage point, Bob's time runs sluggishly, but within the train, Bob perceives everything as normal, unaware of his temporal lag. Should he look outside at Alice, he'd see her stopwatch racing ahead. For eons, humanity adhered to Newton's view of time as a universal constant, smoothly advancing for all. Yet Einstein boldly disrupted this certainty. He unveiled that as an object accelerates towards light speed, its time relative to slower or stationary observers drags, refashioning our grasp of reality into the fabric of spacetime, a seamless continuum where time flexes with motion. These revelations ripple with profound implications. Consider traveling through space at speeds approaching that of light. Upon your return to Earth, your personal clock will reveal that less time has unfurled for you compared to those left on Earth, a venture through time itself. But the strangeness doesn't end here. Returning to Alice and Bob, as Bob's train speeds along, Alice observes not only time's warping but also the train itself contracting in its direction of motion. It appears compressed, shorter than when at rest. This curious occurrence is not an illusion but an intrinsic truth of our universe, unveiling a reality less stable and more enigmatic than previously imagined. As we delve deeper into Einstein's discoveries, remain open to the extraordinary. What seems initially unbelievable may, with a shift in our understanding, expose the underlying structure of existence. As the journey unfolds, grasp that space, time, and the very essence of reality are not as immutable as once thought. The adventure continues, where even gravity and acceleration are poised to surprise. Einstein's curved cosmos. Imagine standing in an elevator, feeling a force pulling you downward. This could be gravity, the familiar push towards Earth's center, or perhaps the elevator is out in space, being accelerated by a spaceship. Despite the different origins, the sensation remains identical, leading to one of Einstein's groundbreaking insights: gravity and acceleration are indistinguishable. This revelation suggested something profoundly different. Perhaps gravity isn't a force as once believed but rather a consequence of spacetime geometry. Consider the swirling motion of water down a drain. Now, visualize this as the way spacetime behaves around massive objects like stars and planets. Instead of a force drawing objects towards each other, these celestial bodies create dips in the fabric of spacetime, similar to that swirling motion. As Earth pulls on you, it's not exerting a force but guiding your path along this curved spacetime. This paradigm shift redefined how we view the universe, moving from Newton's laws to this intricate spacetime tapestry. Such an idea may sound abstract, but it proved itself through real-world predictions. Take Mercury's orbit as a case in point, a puzzle that confounded astronomers. The orbit showed a peculiar wobble that Newtonian physics couldn't explain. Yet, through Einstein's eyes, Mercury's orbit makes perfect sense. Picture a merry-go-round with one seat unpredictably wobbling as it spins. This mirrors Mercury's orbit around the Sun, slightly askew due to spacetime's curvature. Einstein's theories perfectly aligned with this cosmic peculiarity, validating his revolutionized view of the cosmos. As we embrace this understanding, we recognize that the universe operates on principles far different than previously imagined. Space and time are not isolated entities but a unified continuum, where gravity shapes everything not through force, but by the curvature of the universe itself. Einstein's insights prompt us to rethink reality, inviting us to explore a cosmos where our earlier assumptions were merely the starting point for deeper exploration. Join me as we delve further into how these realizations forever changed our grasp of the universe. Bending the cosmos. Imagine growing up convinced the Earth is a vast, flat expanse, only to discover it's actually a globe. This revelation reshapes your entire worldview. Einstein's introduction of non-Euclidean geometry to describe the universe was similarly transformative. Instead of the familiar flat geometry taught in school, Einstein described a universe that's not only curved but also warped. To grasp this concept, picture an airplane journey starting at the North Pole. You fly straight down to the equator, then make a sharp right, covering a quarter way around the Earth, make another sharp right and return to the North Pole. Even with these turns, you end up where you began, having traveled the shortest distance on our planet's curved surface. Einstein coined this strange yet logical path as a geodesic, representing the shortest path in curved space, in contrast to the predictable lines of flat maps. Einstein applied this idea to the vast universe. Despite space appearing flat when we gaze at the sky, he proposed a radical notion: space itself can bend and curve. What crafts these curves? Massive celestial bodies like planets, stars, and galaxies warp space around them. Consequently, objects traversing space aren't merely drifting randomly, like an airplane, they chart the shortest course along these unseen curves, the geodesics of the cosmos. Visualize this as a marble rolling within a bowl, naturally following the curve towards its lowest point. In space, objects meander along curves sculpted by massive objects, perpetually taking the shortest routes. Understanding these geometric principles of space and time is crucial because they reveal how the universe's structure and shape are inherently defined by the matter it encompasses. The contours of space are dictated by the stars, galaxies, and planets around us. This understanding serves as a foundation for exploring Einstein's further ventures into the cosmos, where he pondered not only its intricate design but also its ultimate destiny. Beyond the cosmic horizon. Have you ever found yourself under the awe-inspiring canopy of the night sky, wondering about our place amidst the sprawling universe? Albert Einstein turned this universal curiosity into groundbreaking insights, fundamentally altering our perception of the cosmos. Imagine the universe as a globe, you can traverse in any direction without encountering an edge. This analogy encapsulates Einstein's revolutionary idea that our universe, while finite, lacks the traditional confines we often envisage. It's a perplexing concept, yet relativity stretches our minds beyond ordinary boundaries, reshaping how we perceive reality. Visualize those gleaming stars and distant planets. They aren't just celestial decorations, they mold the universe's structure through the mysterious fabric of spacetime. As vast as they are, these cosmic entities warp spacetime and, as a collective, determine its grand curvature. The density of matter within the universe significantly influences its eventual contours and fate. Imagine the universe having just the right amount of matter, like a perfectly taut bed sheet. Too much mass would cause it to sag, resembling a sheet with a heavy ball in the center, compressing inward. Conversely, too little matter spins a different tale, akin to the dramatic curves of a Pringle chip, rising at the edges and dipping in the center. Such cosmic configurations aren't just theoretical puzzles, they hint at our universe's destiny. Will it continue expanding indefinitely, buckle under its weight, or achieve a harmonic balance? While the answer remains elusive, Einstein laid down the foundational tenets steering our current understanding. Beyond the numbers and measurements, Einstein delved into the philosophical depths of his theory. He questioned if space and time are fixed absolutes or fluid dimensions influenced by perception. This inquiry led him to muse about determinism, pondering whether every event is the inevitable result of prior conditions. Is the universe governed by immutable laws, leaving no room for chance, or is it a meticulously tuned deterministic entity? Einstein also explored the essence of scientific inquiry itself, perceiving theories as more than mere calculations, they embody attempts to unveil the universe's intrinsic order. These theories weave together the observer and the observed, blurring the lines between subjectivity and objectivity. Through this revolutionary lens, Einstein provokes us to contemplate the cosmos and our existence from an entirely new perspective. While his ideas may initially seem abstract, they ultimately reveal the exquisite complexity of reality. Next time you gaze upward, remember that the sky is more than a constellation of stars and galaxies, it's a grand stage of spacetime and matter, echoing the profound intricacies of existence.
As we close our exploration of Einstein's groundbreaking theories, relativity, the special and the general theory, stands as a monumental achievement in reimagining our cosmos. The revelation that light's speed is constant and the universe is curved has profoundly altered our perception of time and space, shifting them from static entities to dynamic constructs shaped by massive celestial bodies. These concepts further intertwine with Einstein's cosmic philosophy, where the universe appears boundless yet finite, inviting us to reconsider the nature of reality. The implications of relativity reach far beyond physics, touching philosophical domains about the universe's fate and the deterministic nature of existence. Einstein encourages a view that transcends everyday intuition, inviting us to see the universe not merely as a collection of stars and planets, but as an interconnected web of spacetime and matter. It's an invitation to marvel at the creation's complexity and our role within its grand narrative.